Hello and welcome to my YouTube channel. So today we are going to study one of the most important topic of quantitative aptitude, that is time, speed and distance. So when you talk of this topic, you will find a problems which are based on three concepts. First, a very simple, that is first concept will be on formula based concept. The formula will be speed is equal to distance upon time. The concept 2 will be problems which are based on trains, and concept 3 will be problems which are based on boats. So here we are going to study all the three types. We will clear first all the concepts and we will see these solve examples based on these three concepts. So stay tuned till the end of this video, and if you have not till subscribe my YouTube channel, first do it. So let us begin our today's lesson. So we are going to learn about time, speed and distance. So basically time and distance, these are related to speed or velocity of a moving object, right? Now speed, we define the speed of an object as the distance traveled by it in per unit time interval. So basically there are three simple formulas are there. One is speed is equal to distance upon time. Now I think everybody knows this formula. Okay, this we have already learned in our schools. If you want to calculate distance, it will be speed into time, and if you want to calculate a time, it will be speed up, it will be what, distance upon speed. Okay, so I think these are the three simple formulas everybody knows. Now let us understand some facts. If the time taken is constant, let's say, see, we have the formula speed is equal to distance upon time. Now in first case, time is constant, so the distance travel will be proportional to speed. That is, more the speed, more the distance travel in the same time, right? So if time is constant, obviously distance travel will be proportional to speed. Second, let's say now speed is constant. So if speed is constant, distance travel is proportional to time taken. That is, more the distance travel, more the time taken at the same speed. Okay. Next, if the distance travel is constant, now in the third case, let's say distance is constant. So speed is what? It will be inversely proportional to time taken. That is, more the speed, lesser will be the time taken for the same distance travel. Okay, so these are the three concepts which are based on formula speed is equal to distance upon time. Now, what are the units of these three parameters, that is speed, distance and time? Now speed, you can measure the distance either in kilometer or meter. You can measure the time in hour, minute or second. So what will be unit of speed? Let's say distance is in kilometer and time is in hour. So kilometer per hour will be unit of speed. So kilometer per hour. Now if you want to convert this kilometer per hour in meter per second, what will be conversion? See, 1 kilometer is equal to 1000 meter, and 1 hour means what? 60 minute and then 60 seconds. So 3600 second. So 1000 divided by 3600, it will be 5 by 18. It will be 5 by 18. So 1 kilometer per hour is equal to 5 by 18 meters per second. And if you want to now calculate 1 meter per second, so what it will be? It will be 18 by 5 kilometer per hour. Okay, so this unit conversion is important. You don't have to, let's say 10 kilometer per hour is given thing, and if you want to convert that 10 kilometer per hour in meter per second. So you should not do every time this calculation 10 into 1000 and divided by 3600. Instead of that, remember 1 kilometer per hour is equal to 5 by 18 meter per second. So let's say 10 kilometer per hour. How you will convert it? 10 into 5 by 18 meter per second. Okay. And x meter per second, it will be how much? Let's say now 10 meter per second is there. So 10 into 18 by 5 kilometer per hour. Okay. So this unit conversion is important. You have to remember this unit conversion. Okay. You don't have to do a calculation every time. Okay. So better you remember 1 kilometer per hour is equal to 5 by 18 meter per second. Next thing. Let us see a simple examples. First example is a Raman can cover a distance of 30 km in 3 hours. In his bicycle, calculate the speed. So what is speed? Speed is equal to distance upon time, right? So speed is equal to distance is 30 km. Time is how much? Time is 3 hours. So 10 km per hour will be speed. Okay, so these are the simple formula based example. We will see it quickly. Next, second example, a Sanjeev can cover a distance of 250 km by traveling at the speed of 50 km per hour. What we have to calculate? We have to calculate time taken by him to cover the distance. So time is equal to what? Distance upon speed. So distance is how much? 250 km. Speed is how much? 50 km per hour. So what will be the answer? Answer will be 5 hours. Next, a train running at a speed of 90 km per hour passes a pole on the platform in 20 seconds. So there is one train which is running at a speed of 90 km per hour, which is passes a pole on the platform in 20 seconds. We have to calculate length of the train. So speed of the train is how much? 90 km per hour. Okay, so see here, time is given in what? Second. So you have to convert this kilometer per hour in meters per second. So 90 kilometer per hour is equal to 90 into 5 by 18 meter per second. So it will be how much? 25 meters per second. Okay, 18 into 5, those are 90. Okay, so 5 into 5, it will be 25 meters per second. So what will be length? See, length of the train in this case will be what? Distance traveled by the train, right? It will be what? Distance traveled by the train in how many seconds? 20 seconds. So how you will calculate length or the distance? It will be speed multiplied by time taken crossing the pole. So what is speed? Speed is 25 and time taken is 20 seconds. So it will be 500 meters. So what will be length of the train? It will be 500 meters. So hope you are getting this problem. These are simple examples which are based on a basic formula, that is speed is equal to distance upon time. Now let us see a concept of relative speed. So first case, let's say there are two objects. Okay, both are having a different speed. So what will be the relative speed between those objects? So let's say those objects in first case, they are moving in same direction. They are moving in same direction like this. Let's say there are two objects, they are moving in right direction. So when the objects are moving in same direction, their relative speed is equal to difference between the speed of the two objects. That means relative speed, it will be S1 minus S2. What are S1, S2? These are the speeds of the respective object. So S1 is the speed of the first object, S2 is the speed of second object. So what will be relative speed? It will be a difference between those speed, S1 minus S2. Now next, let's say these objects are moving in opposite direction like this. Okay, this is what? Opposite direction. One is moving towards right, second object is moving towards left. Okay, When the objects are moving in opposite direction, their relative speed is equal to summation of speed of the two objects. So if the objects are moving in opposite direction, obviously their relative speed will be s1 plus s2. It will be s1 plus s2. Okay, so please remember these both the cases. If the object is moving in same direction, relative speed is difference between the speed of the two objects. And if the objects are moving in opposite direction, then relative speed will be what? It is the addition or summation of the speed of the two objects. Now, this is one of the most important part of whole quantitative aptitude, that is the problems based on trains. Okay, let us see first theory behind it. The trains are the special case in the questions related to time, speed and distance because they have their own theory and situations. The basic relation for the train problem is same, that is speed into time is equal to distance. Okay, the following things need to keep in mind before solving the questions on train. Now the next 2 points are the most important. Okay, so carefully listen to it. So when the train is crossing a moving object, so train is crossing what? Moving object. The speed has to be taken as relative speed of the train with respect to object. Okay, all the rules of relative speed will apply for calculating the relative speed. It is obvious there are two objects, one is train which is moving, right, and there is another object which is also moving. So whenever there are two moving objects, there will be a relative speed. So while calculation you have to take a relative speed, and whatever situation, that is the cases we have seen, that is case 1 if the object and train they are moving in same direction, or case 2 will be object and train will be moving in opposite direction. So we have seen how to calculate the relative speed. So same rule you have to apply here. Next, the distance to be covered when crossing an object. The distance to be covered when crossing an object wherever a train crosses an object will be equal to length of the train plus length of the object. See, the distance to be covered when crossing an object. Let's say a train. Let's say it is crossing an object of length of 5 meter. So what will be total distance covered? It will be length of the train plus length of that object. Okay, so distance to be covered when crossing an object, wherever a train crosses an object, it will be equal to length of the train plus length of the object. So whenever length of the object is given, you have to do the summation of length of train and length of object. Okay, so both these points will be more clear when we will see the examples. Now, there are certain situations this you have to remember. These are the most important. Okay. So these are the most important points. Let us see it. Case 1. Train crossing a stationary object. So object is stationary. Stationary object can be in the form of pole. Let's say there is pole cannot be moving, or a standing human. Okay, without length. So no length of the object is given, as well as the object is what? Stationary. So in that case, the time taken by the train, how you will calculate? LT upon ST. What is LT? Length of train. What is ST? Speed of train. See, this is what time is equal to distance divided by speed. Time is equal to distance divided by speed. What is distance here? Length of the train. What is speed? ST. ST, it is speed of train. LT, length of train. Case 2. Train crossing a stationary object of length. So let's say there is an object. Let us consider a platform. So platform, it will have certain length. So length of object is given. Okay, but it's a stationary object. So whenever there will be stationary object, there is no question of relative speed. Okay, the relative speed will come only into the picture when there is a moving object. There are two moving objects. In this case, in case 1 and case 2, only train is moving while the object is stationary. So we are not talking of what? Relative speed here. So train crossing a stationary object of length. So how we will calculate the time? Time taken is equal to, again, distance upon speed, LT plus LO upon ST. Okay, what is LT? Length of the train. What is LO? Length of the object. And what is ST? Speed of train. Okay, so hope both the cases are clear to you. Next, case number 3 now. A train crossing a moving object without lane. See here. So object is what? Moving. So object, it will have certain speed. So there are two objects, one is train and second is object which are moving. So here we will consider relative speed. So if the train and object are moving in opposite direction, time taken, it will be equal to LT upon ST plus SO. See, opposite direction, addition. Same direction, difference. Okay, so if the train and object are moving in same direction, time taken is equal to LT upon ST minus SO. So what is SO here? It is the speed of the object. It is what? Speed of object. Next, case number 4. Train crossing a moving object of length. So now object is moving as well as it has certain length. In that case, if the train and object are moving in opposite direction, T is equal to LT plus LO upon ST plus SO. So again, opposite direction, there will be summation. In same direction, there will be difference. Okay. So ST plus SO, it is what? Relative speed. ST minus SO, it is what? Relative speed. Okay. So these are the 4 most important cases. If you remember the formula, then in the exam definitely you can crack the problem. So let us see the examples. Let us see example number 1. A train crosses a pole in 15 seconds. In 15 seconds, if the length of the train is 300 meter, calculate this speed. Okay, a train crosses a pole. A pole is a what? Stationary object. Pole is what? Stationary object. So no question of speed, no question of length. Length of the object, length of the pole. So what will be T? T is equal to LT plus SO. LT is what? 300. ST that we have to calculate, and time is how much? 15 seconds. So how we will calculate as ST? LT upon small t. So 300 upon 15, it will be 20 meters per second. Okay, so this is very simple example. Next, example number 2. Now this is important example. Let us see the problem statement. Two trains of length 120 meter and 80 meter are running on parallel lines in the opposite direction. So first important is opposite direction. And length of the two train, it is 120 and 80 meter. Next, the speed of the trains 35 kilometer per hour and 55 kilometer per hour respectively. In what time? What is unknown here? Time they will pass each other. Okay. So what is the formula? Which formula you will use? You will use case number 4. T is equal to LT plus LO upon ST plus SO. What are the two objects here? Objects, both the objects are train. They are moving in opposite direction. So if they are moving in opposite direction, obviously there will be summation in relative speed. So plus sign will be there. Okay. So what is ST plus SO? How you will calculate? ST is how much? 35 plus 55, it will be 90. Okay. Now I am converting this 90 kilometer per hour in meters per second. So into 5 by 18. So it will be 25 meters per second. So just use this formula now. T is equal to 120, that is the length of first train, plus 80, length of second train, divided by speed, that is what? 25. So 200 divided by 25, so answer will be 8 seconds. Okay, is it clear this problem? Very simple. If you remember the 4 cases, definitely you can solve a problem based on train. Next, this is the third concept, which is also very important. That is the problem based on boats and stream. Problems based on boats and stream. Let us see first theory and then we will see the formulas and example. The problem of boats and streams are also dependent on basic equation of time, speed and distance. So speed into time is equal to distance. Let the speed of boat is hb. What is hb? Speed of boat. See, this is what boat, this is what stream. So these are the problems based on boat and stream. Okay, so let the speed of boat is sb and speed of stream is ss. The speed of movement of boat is dependent on whether the boat is moving in which direction. Okay, now if the water is still water, ss will be equal to 0. Okay, so if there is still water, that means there is no a very wavy water flow. Okay, this is what, this is wavy water flow, so it has some speed. So let's say there is still water, ss will be equal to 0 and speed of boat in that case will be sb. Now there are two cases which we have to remember now here, which are very important. First, while moving upstream, okay, let us come to first this figure and then we will see the example. This boat, it is moving in right direction. Is it right? Okay. And the flow of water, it is like this. So can we say these are boat and stream, these are in opposite direction? Or can we say boat is moving against the flow of water? So that is called as upstream, against the flow of water. Okay, now let us consider this boat. Now in this boat, it is moving like this, and the stream is also moving like this. So boat and stream, that is flow of water, it is in same direction. So that is called as downstream or with the flow of water. So boat is moving with the flow of water. So these are the two cases. So in case of upstream, that is boat and the flow of water, when they are in against or they are in opposite direction, the speed of movement is given by upstream speed, SU. This is what upstream speed is equal to SB minus SS. While when moving in downstream, that is with the flow of water, see, whenever there will be, both are moving in same speed. Okay, so both the less effort will require, less efforts will require to move the boat, so there will be addition. So in case of downstream, SD, that is the downstream speed is equal to SB plus SS. Okay, so hope these two cases are important and hope you have got this. What do you mean by upstream? That is the against the flow of water, and what is the meaning of downstream? Okay, now let us see an example based on this. A speed of boat in still water is 12 km per hour and speed of stream is 2 km per hour. A distance of 8 km going upstream is covered in. So there is upstream. So if there is upstream, what we have seen, how you can calculate upstream speed, SB minus SS. So SB is how much? Speed of boat, that is 12 km. So 12 minus speed of stream, it is how much? 2 km. So it will be 10. So time is equal to distance upon speed. Distance, it is of 8 kilometer divided by 10 kilometer per hour. So 8 by 10 into 60, it will be in minutes. So 1 hour is equal to 60 minutes. So that's why I'm multiplying this answer by 60. So you will get 48 minutes. Okay, next. So what we'll do, we will stop here. I will make the second part of this where we will see a different solve examples. So hope these three concepts are clear to you. So we have seen a basic examples based on a simple formula, speed is equal to distance upon time. Then we have seen a concept of train, and the third concept, the concept of what? Boat and stream. So hope you have liked my this video. Please do share with your friends if you are finding this useful. So we will quickly meet in the second part with different solve examples based on this topic. Till then, take care. Have a nice day. Thank you.